In 2006, our solar system lost one of its planets, Pluto, the once beloved ninth planet. But it didn't disappear into the void of space. Instead, Pluto was stripped of its planetary title and cast out as a cosmic outcast. Scientists, students, and space enthusiasts were left divided, sparking a heated debate that went far beyond Pluto's size or distance from the Sun. Was Pluto simply too small? Too far away? Or was there something deeper behind this dramatic demotion? In this video, we'll uncover the truth behind this controversial decision and reveal why Pluto's story is far more fascinating than it seems. The story of Pluto begins in 1930 with a young astronomer named Clyde Tombaugh. Working at the Lowell Observatory in Arizona, Clyde was tasked with an incredible challenge: to find a mysterious Planet X. Scientists believed that a hidden planet beyond Neptune was influencing the orbits of its neighbors, and Clyde was determined to uncover it. Using a method called blink comparison, he carefully studied photographs of the night sky taken weeks apart, searching for a faint dot that shifted positions. After months of meticulous work, he found it, a small, distant object that would become known as Pluto. When Pluto was discovered, it was immediately celebrated as the ninth planet in our solar system. At the time, scientists believed it was a large world, possibly similar in size to Earth. Pluto's distance from the Sun, an average of 5.9 billion kilometers, placed it far beyond Neptune, in an uncharted region of the solar system. Its mysterious location, coupled with its apparent orbit around the Sun, fit the criteria for a planet based on the scientific understanding of the time. The discovery was monumental, marking the first addition to the solar system since Neptune in 1846. Pluto's classification as a planet captured the imagination of the public and scientists, solidifying its place in astronomy textbooks and popular culture for decades. Pluto's size was initially overestimated. Later discoveries revealed it to be much smaller than Earth. In fact, it is only about 2/3 the size of Earth's moon. Yet its charm remained undeniable. One of its most iconic features is the heart-shaped Tombaugh Regio, a bright, icy expanse named in honor of Clyde Tombaugh. This heart-shaped structure captures the imagination and hints at Pluto's dynamic and ever-changing surface, shaped by glacial activity and possibly even ice volcanoes. Pluto's atmosphere and orbit add even more wonder to its story. It takes an astonishing 248 Earth years for Pluto to complete one orbit around the Sun. During this lengthy journey, its thin atmosphere, composed mostly of nitrogen with traces of methane and carbon monoxide, undergoes dramatic changes. When Pluto is farthest from the Sun, its atmosphere freezes and settles onto the surface like frost. As it approaches the Sun, the frozen gases vaporize, forming a delicate, temporary atmosphere. Temperatures on Pluto can plunge to a bone-chilling minus 230 degrees Celsius, making it one of the coldest places in the solar system. Pluto's orbit is as unique as the world itself, elongated and tilted, unlike the nearly circular orbits of the planets. At times, it even travels closer to the Sun than Neptune, but a perfectly synchronized cosmic alignment ensures the two never collide, performing a celestial dance across the solar system. Accompanying Pluto on its distant journey are its 5 moons, each adding to its mystique. Its largest moon, Charon, is so massive relative to Pluto that they orbit a shared center of gravity, behaving almost like a double planet. Meanwhile, the smaller moons, Nix, Hydra, Kerberos, and Styx, form a miniature celestial family, gracefully circling their icy parent in a mesmerizing display. The story of Pluto took a sharp turn as astronomers ventured deeper into the outer reaches of our solar system. Beyond Neptune lies the Kuiper Belt, a vast, icy region teeming with countless small, frozen worlds. Pluto, it turned out, was not alone. This discovery marked the beginning of a new chapter in astronomy, one that would eventually challenge Pluto's status as a planet. In 2005, astronomers discovered Eris, an icy object located even farther from the Sun than Pluto. But Eris wasn't just another Kuiper Belt object. It was slightly larger than Pluto. This raised a provocative question. If Pluto is a planet, shouldn't Eris be one too? Suddenly, the solar system seemed much more crowded than anyone had imagined. If every large object in the Kuiper Belt were classified as a planet, our solar system might have dozens of planets, not just 9. Astronomers found themselves at a crossroads. The discovery of Eris forced them to confront a critical dilemma. What exactly makes a planet a planet? Until then, the term planet had been more of a general idea than a precise definition. But with new discoveries piling up, it became clear that the rules needed to be rewritten. In 2006, a monumental decision reshaped how we see our solar system. The International Astronomical Union, or IAU, a global organization of astronomers responsible for naming and classifying celestial objects, stepped in to address a growing question. What exactly makes a planet a planet? With discoveries like Eris challenging Pluto's status, it was time for a clear universal definition. After extensive discussions and debates among astronomers worldwide, the IAU introduced a formal definition for the term planet. They established 3 essential criteria that an object must meet to earn the title. First, the object must orbit the Sun. This excluded moons and other bodies orbiting planets. Second, the object must have enough mass for its gravity to pull it into a nearly spherical shape, distinguishing planets from irregularly shaped asteroids or comets. Finally, the object must have cleared its orbit, meaning it must dominate its orbital zone by either consuming or ejecting smaller bodies near its path through gravitational interactions. While Pluto met the first 2 criteria, it failed the third. Pluto orbits the Sun and has enough mass to maintain a spherical shape, but it shares its orbital region with countless other icy objects in the Kuiper Belt. Unlike the 8 planets, Pluto does not exert gravitational dominance in its zone, as its mass is too small to clear away other objects from its path. As a result, Pluto was reclassified as a dwarf planet, a new category introduced by the IAU to describe celestial bodies that meet some, but not all, of the criteria for a planet. This decision to reclassify Pluto sent shockwaves around the world. For decades, Pluto had been celebrated as the quirky 9th planet in our solar system, a tiny, icy world that captured the imagination of both scientists and the public. When the IAU declared Pluto a dwarf planet because it didn't clear its orbit of debris, many people took it personally. The announcement ignited a wave of outrage, with countless fans of Pluto standing up to defend its place in the planetary lineup. The debate soon became a cultural phenomenon, with Pluto lovers rising up in defense of the dwarf planet. These passionate supporters argued that Pluto's long-standing status as the 9th planet should not be dismissed so easily, claiming that the new scientific definition was too narrow and didn't account for Pluto's unique place in the hearts of millions. Some even suggested that the IAU's criteria didn't reflect the complexities of the solar system. On the other side, those supporting the decision emphasized the importance of a clear and consistent definition, one that would account for the discovery of other similar objects, like Eris, in the Kuiper Belt. Pluto's journey from being the 9th planet to a dwarf planet isn't just a tale of reclassification. It's a story of how science evolves as we uncover more about the universe. Its demotion wasn't a downgrade, but rather a reflection of how far we've come in understanding the complexities of our solar system. By redefining what it means to be a planet, astronomers not only made room for discoveries like Eris and the Kuiper Belt, but also opened our eyes to the incredible diversity of celestial worlds beyond Neptune. Instead of mourning Pluto's lost planetary status, perhaps it's time to embrace it for what it truly is: a unique and fascinating world with a heart-shaped glacier, mysterious cryovolcanoes, and a story that continues to inspire curiosity. Thanks for joining us on this journey through Pluto's story, from its discovery to its reclassification and beyond. If you enjoyed exploring interesting stories with us, don't forget to hit that subscribe button. What topics do you want us to dive into next? Let us know in the comments. Join us as we get animated about science here at Animated Science.